Welcome to Techno Herald Online. Today we are going to start lesson 7. In lesson number 7 we will study about electric potential and relationship between the electric field intensity and the electric potential, which is also the second Maxwell equation.
So let's see, what do you mean to say by electric potential? Suppose that this is an electric field present in a space. Okay? This is an electric field present in a space, and this is a random path. Okay? Let on this part we take 2 points A and B, and we wish to suppose that a plus Q charge is present on this path, and we wish to move this plus Q charge from the point A to the point B in this electric field E. Then, since it is a point charge of magnitude plus Q present in an electric field E, then due to this electric field, a force will act on this point charge. Okay? Due to the presence of this positive charge of the magnitude plus Q in this electric field, a force will act on this plus Q charge. Due to this force will restrict the motion of this plus Q charge. If any person will try to move this plus Q charge from this point A to the point B, then he will have to do some work in moving this plus Q charge. Okay? So this is how the concept of the potential gets developed. So if any person wishes to move this plus Q charge from the point A to the point B in this electric field, then he have to spend some energy in order to move this plus Q charge. This is because due to the presence of the electric field, a force will act on this plus Q charge, and it may either assist the motion of the plus Q charge, or it may either ये क्या करेगा कि plus QE, the force which is acting on this body, acting on this charge, ये क्या करेगा, either it will assist its motion or it will restrict its motion. So whenever it restricts its motion, the external agent need to work upon this in order to move this plus Q charge. So suppose that this is a elemental length dl over this path. This is the elemental length dl over this path. Then dw, what is dw? Work done. dw is work done in moving plus Q charge through the length dl. Okay? Through the length dl. This is given as minus F dot dl. We know that from our knowledge from the mechanics, we know that work done is given by, from mechanics we know that work done W is given by minus F dot dl. Okay? So here also dw, that is work done in moving a plus Q charge through the length dl over this path L. Let this path be L. Let us denote this path as L. Okay? So in order to move this plus Q charge through this elemental length dl over this path L, What is the work done? That is minus F dot dl. And what is the significance of this minus? This minus indicates that this work is done by the external agent. That is, this minus indicates that the work is done by external agent against the force acting on this plus q charge. And what is F here? F is, what is the force acting on this plus q charge when in this electric field? Force acting is Q into E, that is the force acting on this plus q charge. So this is equal to, so dW is equal to minus QE dot dl. Okay, this is dW. Now if we integrate this elemental work done from the point A to the point B, then we can find the total work done in moving this plus q charge from this point A to the point B. Okay? Now, if we integrate this dW over the whole path, that is from point A to the point B, we will be able to find the total work done. So total work done in moving plus q charge from point A to the point B is given by W is equal to minus integration of QE dot dl